we have a couple of problems dealing with the dot product. So the dot product, let's say the dot product vector v that has two components, v1, v2 dot with the vector that have w1 and w2. I write the vector in this notation. Then the dot product will be the sum of the products of the components, corresponding components. So v1 w1 plus v2 w2, right? And then we find the angle between the vectors, and then we will say if they are parallel, orthogonal, or neither. Right. First, the vector v is I minus j. So pretty much we can say 1i minus 1j. So if we write as the component, vector v is going to be equal to 1 and minus 1. Likewise, vector w is going to be equal to 1 and 1 in that notation. So we have v dot w, vector v dot vector w, v is 1, negative 1, dot 1 and 1. So the sum of the products, 1 times 1 plus negative 1 times 1, and that equal to 0. Right? We'll see what it means by that in a minute. Right, the angle between two vectors. So what we have is when we find the dot product between two vectors, it is equal to the magnitudes of v times the magnitudes of w. Notice that product, there's nothing in the middle. So the vector magnitudes of v times the vector of w times the cosine of the angle between them, and this time we look for the angle. So we will divide by v by the product of the magnitude. So we have cosine of theta equal to the dot product divided by the product of the magnitude, and that gives us the angle between two vectors. Right. So we'll do the math here. We say cosine of theta equal to v dot w. We already have that, but let's just copy the formula here. And the magnitude of v, the magnitude of w. Right. The dot product we already have done that, which is 0, so that is 0. The magnitude of v, this is the vector v, Pythagorean theorem, 1 square plus minus 1 square times w is that, so will be 1 square plus 1 square. So we'll have 0 over anything that is not 0. At the bottom we have square of 2 and square of 2, so what bottom line is going to be 0. So cosine is equal to 0, so theta is cosine inverse of 0, because we know that unit circle cosine is the x values. The x value is equal to 0. It's going to be equal to this point or this point. But the angle between two vectors only between 0 and 180, so it has to be this one. So it's going to be 90 degrees. And if it is 90 degrees, it is orthogonal. That's the first problem. We do pretty much the same thing, but this time we have different problems. So first, again we write the vector v as 3, comma negative 4. That is the vector v, and the vector W is negative 9 and 12. So the dot product, the formula for the dot product is this, and the angle between two vectors is this. I'm not going to write that out again. So the dot product, the vector 3 and negative 4, dot with negative 9, 12. So we have 3 times negative 9 plus negative 4 times 12. So that gives us 3 and negative 9. That's negative 27, negative 27, negative 48, 27, 48. That gives us negative 75. Right, it's negative. Next we find the angle between two vectors. Again, the dot product gives us that, and so the angle between two vectors is cosine inverse of this ratio. Anyway, I still write cosine of theta equal to the dot product over the product so we have cosine of theta V dot W. We already did that, which is negative 75, and the magnitude we use Pythagorean theorem, 3 square plus negative 4 square times negative 9 square plus 12 square. Right. So we have negative 75, and 3 square and 4 square, that will be 5, and 9 square and 12 square, that is 15 square. So we have 5 over 15, and do that we have negative 1. So cosine is equal to negative 1, and on the unit circle, when x equal to negative 1, it had to be this point. So theta equal to cosine inverse of negative 1 is 180 degrees, and we know 180 degree is going to be parallel, because one in that direction and one the other direction, but the vectors will be parallel. That's what we have.